So we're on part 4 of this question, and we want to know if we should reject the null hypothesis at the 0.05 level. So before I decide yes or no, what I have to do is find the critical values. And we're going to use the 0.05 for that. So how I do this is I draw the normal distribution. And because this is a two-tail test, we have two critical values. We have one here and we have one here. So we had 0.05, that's the total area in the tail, which means that half of it goes into the left-hand tail and half of it in the right-hand tail. So I just divided that 0.05 by 2 to split it between the two tails. So now we want to find our critical values. And I can find my first critical value by using the inverse norm function. So the question is, what value cuts off the bottom 0.025 in the left-hand tail? So to find this, we're going to do inverse norm. So this gives us a boundary value given an area of 0.025. And the mean is 0, standard deviation is 1 if the calculator makes you do that. And when I enter that, I get, negative 1.9599, so that rounds to 1.96. Even though it says round to 3 decimal places, it rounds to 1.960. So that's how we get that left critical value. And then the right critical value I can find by finding this area, which is 1 minus 0.025. So I'll do that over here, inverse norm. I can really just type it in that way, 1 minus 0.025. And I can put in the 0 and the 1 if I need to. And that gives me 1.96. Now usually what I do is I just go with this. I have negative 1.96. I know that that's here. So then this one is going to be positive 1.96. The critical values are always symmetric when we're working with the normal distribution. So now we've got negative 1.96, 1.96. And the question is, where does your test statistic fall, negative 2.81? Well, it falls somewhere out here, which is in the rejection area. So that's why we're going to reject the null hypothesis, and we have those two critical values. And that's how you do that problem.